Hi, my name is Casey, and in this video I'm going to tell you a little about the KISMET project. Our objective is easy to state. We want to generate knowledge that will help us better understand and then mitigate some persistent threats to the security of the infrastructure of the Internet. It has never been clearer than now how critical Internet infrastructure is. It is literally holding society and much of the economy together this year. But the focus of this project is what holds the Internet together. Users tend to think of the Internet in terms of its applications, and there are well-known challenges to security and trust at that layer. Fake news, identity theft, ransomware. Our focus is on the plumbing under the hood, so to speak, the systems that move packets of data from source to destination, and key services on which all applications essentially depend. The security flaws at these layers undermine the application layer and facilitate attacks on that layer. In this short video, I can't go into detail on these systems and the security threats to them, but in a nutshell, the problem is lack of authentication in these three fundamental subsystems of the Internet architecture: addressing, routing, and naming. First, an endpoint can falsify its address and pretend to be another point, enabling a well-known class of attack called a spoofed denial of service attack. Second, a region of the network can pretend to be another region, and the routing system will believe this, with the result that traffic intended for the legitimate region is deflected toward the attacker. This attack, called a route hijack, has been used for a variety of purposes, including massive click fraud and theft of cryptocurrency. Finally, the domain name system, or DNS, which maps names like mit.edu into an internet address, is critical to both legitimate and malicious users. Attacks such as malware or phishing are normally launched from malicious websites, and these sites need URLs just like any legitimate website. Current operational practices make it easy for malicious actors to hijack or obtain their own DNS names and use them for abusive purposes. One estimate from April of this year is that there were about 750,000 such names. I'm describing these challenges in simplistic terms, but what constitutes malicious behavior? Who should be empowered to judge or act? And will one or another potential intervention cause unacceptable collateral damage to legitimate users? The two leaders of this project bring their respective skills to these issues. I'm KC, and I've spent over 30 years pursuing and enabling others to pursue scientific study of the Internet by gathering and sharing the best available data about the Internet infrastructure.
I have spent over 50 years at MIT developing the design principles of the Internet, working on Internet security, and arguing for evidence-based progress both in technology and policy. And we are complemented in this project by a multidisciplinary team of collaborators from academia, industry, and government. Why do we think we can succeed when the challenges have persisted for so long, in some cases decades? The technical community tends to think of remedies in technical terms, such as the development of new protocols. Development of technology may not be the right approach, nor is it a complete approach. Proposing a new protocol is difficult. The standards process can trigger extended unresolved debate about the best option. There's a famous case where a working group in the Internet Engineering Task Force spent 5 years in fruitless debate about the best path forward to improve routing security before it was finally disbanded. And just proposing a new technology does not mean that various actors in the Internet ecosystem are motivated to deploy it. Deployment may be costly, can have undesirable side effects, and bring benefits only to others.
We believe that the best path forward is to focus more pragmatically on finding and encouraging enhanced operational practices that can bring benefit. We've identified 3 specific sorts of knowledge that are required and will be the focus of our open knowledge network. First, we need to identify practices that actually improve security, which is tricky because attackers can adapt. Second, we need to make the case that operators that implement such practices actually benefit. This involves knowledge about business issues and incentives rather than technology, and traditional standards bodies just do not go into those considerations. Finally, if operators make a commitment to undertake enhanced practices, we need knowledge to measure compliance. There's a lot more we could say about the problem, why we see reason for optimism, and the paths forward that we have identified. We invite you to talk to us during the National Science Foundation's Convergence Accelerator EXPO 2020. Thank you.